Good morning, this is your Stat Sensei, Mr. Sensei, and this is contingency tables, and this is a review from Unit 2 because we're going to learn how to build them after this, but for right now, we just want to review how to read them. So, 1 in 8 women will have breast cancer sometime during their lives. Many women have annual mammograms after age 40 to screen for breast cancer. Mammograms are not perfect and sometimes produce false positives and may also produce false negatives. In Stone Oak, 6% of women over 40 currently have breast cancer. 99% of the time, the mammogram will detect the cancer in women with breast cancer. The probability of a positive mammogram in women who do not have cancer is 0.03. Create a table showing all of your work. So, I want to look at the table real quickly. You'll notice this part highlighted in pink. This is what is known as joint probabilities because they involve two, cancer and positive. So if I have to use the word and because it involves two, it's a joint, which because we see this as a intersection, is where the two come together. So cancer and negative. So once again, positive and no cancer, or no cancer and positive. Once again, I'm using the word and. So if I'm using the word and, it's an intersection, it's a joint probability. Those on the outside, well, the one is just a total. It's not a marginal. This is just a total, the total probability. A marginal probability, we don't really care about the positive. We're just saying, hey, they have cancer. Here they have no cancer. Here it's positive, here it's tentative. They haven't told you when it's positive, they didn't tell you whether they had cancer or no cancer. It could be either or. So this is only involving one thing. It's just, oh, the test was positive. Oh, the test was negative. So it's only involving one thing, whereas the joint involves two. The marginal really only involves one, or gives us information about one. So it says, what's the probability a randomly selected woman does not have breast cancer? I always want you to get used to setting up these as a fraction initially, even though this time we're dealing with one, because sometimes we're going to be dealing with actual frequencies as opposed to probabilities. So the probability does not have cancer, well, that's going to be 0.94 over 1 whole. The next one, what's the probability a randomly selected woman tests negative for breast cancer? Well, negative 0.9124, so 0.9124 over 1, because that's our negative. What's the probability a randomly selected woman tests positive for breast cancer? Well, positive is 0.0876, so 0.0876 over 1. What's the probability that a randomly selected woman tests positive and has breast cancer? So now we are looking for an intersection. So positive and has cancer. Oh, okay. Now I don't see the word given, so I'm just looking for the intersection. I'm looking where there's two streets cross. So my two streets cross here. This is my intersection. So 0.0594 over 1. What's the probability a randomly selected test woman tests negative and has breast cancer? Well, let's look. Where's test negative? Here's test negative. And we're looking for has breast cancer. Once again, we're looking for where the two streets cross. Well, they cross at 0.006. So 0.06 over, or 0.006, the intersection where the streets cross over 1. What's the probability a randomly selected woman tests positive and does not have breast cancer? So looking for positive, and this is our positive group, and does not have cancer. Well, guess what? This is where they intersect, 0.0282. So in this case, 0.0282 out of the whole. And it's always going to be out of the whole unless they tell us it's like a given statement. Given, and by the way, I'm going to switch over. So the next one is, given that a woman tests positive, what's the probability she does not have breast cancer? Well, remember, if it's given, it's always going to be intersection over given. So in this case, what were we given? Given that the woman tests positive, That tells me 0.0876 is my denominator. What's the probability she does not have cancer? Well, I need my intersection, which in this case is 0.0282. So 0.0282 divided by 0.0876, truncate at 4 decimals. Okay. Please don't forget, it's always, every single time you see intersection over given. So where the streets cross divided by the whatever you were given, and we were given that she tests positive. So given this, that's my denominator because that's what we were given, and my intersection is where the streets cross. It says explain the difference between F and G. F was what's the probability randomly selected and does not have breast cancer. Well, here we were taking it out of the whole amount, the entire population. Here we were given she tests positive. All right. G is only out of the group that tested positive because that was given. All right. This part was given and this was taking out the whole amount. Moving on to I. Given that a woman does not have breast cancer, what were we given? We're given they do not have cancer. So intersection over given. So this is what I was given. So this is my denominator. What's the probability she tests positive? Well, testing positive, so 0.0282 over my what I was given. Oh, I'm sorry, I read that wrong. Given a woman does have breast cancer, I thought it was does not have breast cancer. I did that completely wrong. I apologize for the misleading you. Given they have cancer, what's the probability they have cancer? 0.06. What's the probability they test positive? 0.0594. So intersection over given, and that's 0.99. Because I messed that up, I'm going to move to a new page. Given that a woman does have breast cancer, what's the probability she tests negative? So given she has cancer, well, this is what it's always intersection over given. Can't stress that enough. Intersection over given. Well, what was I given? We were given this. So this is my denominator. What is the probability she tests negative? Well, negative, there's my intersection of 0.006. So 0.006 divided by 0.06 is 0.01. Given a randomly selected a woman tests positive, what's the probability she has breast cancer? So we're given that she tested positive. That's what we were given. So that's where we start. So that's my denominator because that's what I was given. What's the probability she has breast cancer? Well, here's my intersection, 0.0594 over 0.0876. So there's about a 68% chance she has it given she tested positive. Given that a randomly selected woman tests negative, what's the probability she does not have breast cancer? So testing negative, this is what we're given. So we're given this, so that's my denominator. What's the probability she does not have breast cancer? Well, my streets crossed right here at 0.91184, 0.9118. So that's my probability, my intersection over my given. And given that a woman does not have breast cancer, so we know in this case they don't have breast cancer. So this is what I was given. So I'm given this at 0.94. What's the probability she tests negative? Well, where does the streets intersect? 0.9118. All right. L and M, explain the difference between L and M. So L says, given a randomly selected test negative, what's the probability she does not have cancer? given the woman does not have cancer, it's probably she tests negative. So we're going to have the same intersection. They cross at the same spot, but the givens were different. All right. So L and M have the same intersection, but L is out of the group that tests negative. So this is given that they test negative, while M is given that a woman does not have breast cancer. So even though they have the same intersection, they have different givens. And that's the difference in why they have different answers. All right. I appreciate you watching. I hope this helped, and I look forward to seeing you on the next one. Thank you.